Hey, hello guys, welcome back to my channel Data Science with Gagan. So here in this video I'm going to share a very interesting project which is question and answering system, where we'll be using large language model with LangChain with following RAG architecture. So as moving further, we will go through some concepts of RAG and its architecture, and as LLM we are going to use T5 model, so we will go through T5 model and it's working as well, and in the end we will go through its implementation, like how can we implement RAG with LLM for this question and answering system to make it more robust. Okay, so first we will go through RAG. So let's start with RAG. So here it's the working architecture of RAG, where system is taking the input from the user as query or prompt, and then it's calculating the embedding for that particular query prompt. Then, on the basis of embeddings, it is finding out the relevant context or relevant information from the knowledge source. Here you can see, and then once the system has relevant context, then it is giving that relevant context and prompt or query to the LLM, and then LLM based on the prompt and context is generating the response, and the system is returning that response to a user. So this is how the RAG architecture works. Now, what is RAG? So, RAG stands for Retrieval-Augmented Generation. It is an evaluation in Gen AI methodology which enhances the capability of Gen AI in generating the more optimized output with the more targeted information. And that targeted information can be more up to date than LLM, as well as specific to a particular domain. And now here you can see RAG is consisting of three components. One is R, A, and G. Now what R does? Now R used to look up the R used to look up the external data sources like web pages, APIs, and dynamic DBs to retrieve the relevant information, or you can say to retrieve the relevant context. So that's what we are doing here. Now what is A? Now A used to add the retrieved information to the user prompts. So this is the first step here. Now what G does? Now G uses LLM to generate response to user prompt with the context. So this is what we are doing in the fifth step here. So this is the small picture of RAG. So if you want to learn more about RAG, so I have mentioned one link in the video description, so you can go through it. Now let's come to T5 model. So T5 stands for text to text transfer transformer. This model is a versatile language model developed by Google Research, and it is designed to perform a wide variety of natural language processing tasks using unified framework. And it is a model architecture. Its model architecture is based on transformer architecture with an encoder and decoder structure. So that's what you can see here. We have encoder and decoder, and then we have internal part of encoder. You can see, like, we have a stacked encoder here and stacked decoder here, and top of those we have a linear layer, and we have a softmax activation function which decides the which words will be the next, right? And to learn more about T5 model, you can go through the link that I have mentioned in the video description. If you want to learn more about, then click on the link. Now here you can see, so here in this project we are going to use Pinecone vector DB to store our embeddings. Now let's, so here you can see this is the flow chart of this project, where we will first reading out where we are reading out the data from the PDF file or the text file, and then we are creating the chunks, mean we are breaking the data into chunks of the same sizes. Then we are calculating the embeddings. So to calculating the embeddings, we are using Hugging Face embeddings, and then post calculating the embeddings for each chunk, we are storing all those embeddings into a vector DB, means we are storing all those embeddings into a Pinecone vector DB. Now then, once the user will give the query, we will calculate the query embedding of those query, and then find out the relevant context from the vector DB, and then we'll find out the top k matches, and then we'll return top k matches with query to the LLM, and then LLM will take both query and the relevant context and will generate the answer, and then we will return the answer to the user. So this is what we are going to do in our project. So let's start with the coding part. Means, like, now from here we will see the implementation of our RAG architecture with LLM. So here you can see in this cell we are importing all the libraries, like first we are here you can see here first I'm importing the CSV loader, as we are having data in the CSV file. And then we have then we are importing character text splitter. So we are going to use this library or you can, this class, to create the chunk out of our data. And then I'm importing Hugging Face embedding to calculate the embeddings, the chunks that we have created so far. And I'm calling load QA chain to create the chain which will and in this chain we are going to feed large language model, right? And then which will take the input from the user and it will generate out the query. Then it will generate out the response. And then here you can see and then I am importing Hugging Face hub. We are going to use this class to call the T5 model from the hub. And then Pinecone and serverless spec to create the object of a Pinecone DB, so we can store our embedding on the vector DB, and or we can fetch out all the embeddings from there, right? So here first I'm setting up the APIs here, and then here I'm loading the textbook data.csv using CSV loader, so we can have our data into a documents. And then here using the character text splitter I'm creating the chunks. So here you can see I mentioned 1000, so this is going to be a chunk size. Now we have created 508 chunks, and each chunk is of 1000 size. But now for each chunk we have to calculate the embeddings, right? So for that purpose, in the 26th line you can see I'm calling up this class Hugging Face embeddings, and using this class we are going to calculate the embedding for each chunk. So in the 28th cell we are going to check, what is going to be our output, what is going to be our output size of embeddings. So for that purpose I'm running an example for how are you. For that example you can see we are getting the embedding size is of 768, and that particular size we are going to use to create an index in a vector DB, which will tell the DB that we are going to store embedding of this size in future. So let's move further. In the 30 cell, you can see I'm creating up the object for my Pinecone DB. So while creating Pinecone DB, we will have to provide the API key. So instead of this, you will have to provide your API key. So to get your API key, you will have to go to the Pinecone DB website, and there you will get the API key section. Once you will click on the API key section, you will get the API key here. If you don't have, then you can create your own API key here. Once you will get the API key here, you can copy from here and paste it over here. Once you will create the once you will create the Pinecone DB object here, you can go to the next cell. Then you can see in the 32nd line I'm giving this name, and then in the 33rd cell I'm creating up this index in the Pinecone DB. So here you can see I'm creating this index with this index name Q&A, with this dimension, with this cosine matrix. So what this cosine matrix reflects, it reflects that we are going to perform a cosine similarity search, right? Then post that, once you will create your index here, it will reflect here in the index section. That's what so we have created a question and Q&A index there, so it's reflecting here. Once you will create the index there, you can call up your index with your index name here. Now once we will create the index, we need to upsert, or we have to store the data, right? So here that's what we are doing here. First we are calculating the embeddings for each chunk, right? And then once we are done with this thing, we can upsert the data to our DB. That's what we are doing here using our index. So once you will upsert all the embedding data into your DB, it will reflect here. So how it will reflect, once you will click on Q&A or on your index. So initially when you before upsetting the data, the vector count will be 0, and post upsetting the data, the vector count will increase. So that's what you can see here. We have a vector count of 166 here. So this is how we have created the Pinecone DB index. So here you can see I have written one custom function which is retrieve relevant context, and it is taking some parameters: question, index, top k, Docs embeddings. So question means the query the user is going to give. Index, the index means the index we have created above for our DB. And then we have docs. Docs mean the chunks that we have created above from our data. And then we have top k. Top k means the top end results that we will get from the vector DB. And then we have embeddings. Using this embeddings, we are going to calculate the embedding for our question and for our or for our query. Now let's see what this function is doing. Then in the first step, we are calculating the embedding for our question or for our query. Once we are done with this embedding calculation, we are giving this embedding to this function means index.query. Basically, here we are running a query on our vector DB to find the relevant context. Means what it will do, it will perform a cosine similarity search. The result that we get from the cosine similarity search, from there we will take the top k results. Once we are done with this thing, we are finding out the indices on the basis of this result. Once we are done with this indices, we can easily find out the actual text from the docs with this indices, and then in the end we are returning those actual text as context. So this is what this function is doing. And then here you can see in the 50th cell, I am creating one LLM. How I'm creating one LLM, here you can see I'm calling up this model which is Flan T5 base. So we have multiple variant of this T5 model. So here I'm using base, but we have small model as well. We have large and Excel model. So you can call any function as per your model, as per your system requirement. So as per my system requirement, I'm calling up this model. Here you can see I'm giving this two parameters, temperature and max length. So temperature represent the variability in your output, and the max length represent the output length of your response. Once I'm creating this, once I will create this LLM. Now we can here I'm creating one chain using load QH chain where I'm giving this LLM. So what this chain will do, it will take the question and the context, and on the basis of your context and question, it will generate the answer. So that's what we are doing here. Here you can see I have created one demo, question and answer demo. So first demo is like where I'm giving this question, what is SI unit of time. Here in the context, I'm finding out the relevant context based on my DB, and then here I am giving this context in the question to my chain, and then when I will run this chain, it will return an answer as second. So similarly, I have another example. What is volume? So first it will calculate. First it will find out the relevant context based on this question, and then when we will give this context and question to this chain. The chain will generate this answer, measure of the amount of space occupied by an object. So this is what we are doing here. We are giving a question to a model, and the model is generating the answer for our question. So till now we saw we had created some questions, and we got the answers for those such questions using T5 LLM with following RAG architecture. But one question which arises here, which is, what if we don't use RAG architecture? We use only LLM to generate the answers for our questions. So what is the difference between what if we don't use RAG and what if we use RAG? So this is what I have mentioned in my RAG block, where I have created one comparison table where I'm showing the comparison between pre-trained model, pre-trained plus fine-tuned model, and pre-trained model with RAG. So here these values, low and high values, represents the difference. So in the case of pre-trained model with RAG, you can see the training cost is low, complexity is low, the domain knowledge will be very high because it is very specific to a particular domain. It is very up to date because we have a latest data in our knowledge source. Then explainability will be high, and the hallucination avoidance will be high, right? Whereas in the case of pre-trained LLM, right, you can see a low value of, yeah, obviously we are not fine tuning it, so we have a low training cost, complexity is low value, and it is not having such domain knowledge. That's why we are having low value here. Yeah, it's up to date, and explainability is also high, is having a high value, but hallucination is having a low value here. what if we use pre-trained fine tune? What if we do fine tuning or pre-trained LLM? So in that case, obviously, if we will fine tune this pre-trained LLM, we need more training cost, right? So that's why we can see the high value for the training cost. The complexity will be high. So obviously, we are if we are fine tuning this model for one specific domain, then the domain specific knowledge will be high. Then yeah, up to date for up to date we are having a low value, explainability will be will be low, and hallucination avoidance will be high. So this is what the difference between pre-trained model and pre-trained model with the RAG. Hope you got my point. What if we use RAG with what if we use LLM with RAG, and what if we use only LLM? So this is all about this video where we saw how can we create question and answering system using any LLM with following RAG architecture. So yeah, that's all for this video. Thank you guys. Stay tuned for the next video. And see you guys in the next video. We will see the another project. Bye. Before leaving this video, please do like and subscribe my channel to keep me motivated so I can create many more videos for you guys on data science projects. And please don't forget to press bell icon to get the notification for the next video. Thank you guys.